Alright, we're going to talk about another reaction in Module 6. This reaction is actually a part of precipitation reaction. We learned one of the precipitation reaction already, which is called a double replacement. If you can take a second to quickly recap what it was like. Basically, two ionic compounds, they're going to exchange a cation and anion. Okay, that's called a double replacement reaction. And because you're always going to produce one of the products to be insoluble in water, that's why it's called precipitation. So here we're going to learn another precipitation reaction. It's called a single displacement reaction. Alright, so what is single displacement reaction look like? And here's an example, okay. You can see there's a solid calcium, which is a metal, react with an ionic compound. Now, quickly question, okay, what do you think the charge of calcium is? Okay, so it's not positive 2 in this case. When it's a pure element, the charge is actually 0. Okay, whenever we talk about the charge of a metal or non-metals, positive 1, positive 2, negative 1, negative 2, that's when we were saying they are in a compound, okay, like this copper. But when any element, doesn't matter or non-metal, okay, when it's by itself, or like there's nothing else around it, that means it's a neutral element, okay. So this neutral element will react with this compound. Since there's a copper and NO3, okay, you can quickly change yourself what is it. It's called a nitrate, okay? And it does have a charge of -1, if you remember. So when you look at this chemical formula, you should immediately realize that this is a copper, but it's a type 2 metal, okay? So when you name it, you should write out copper with a charge in the parentheses and followed by nitrate. Now this NO3 is nitrate. The parentheses 2 here, that means basically there's one copper and there are two NO3s. Okay, so the first little number 3 is part of the polyatomic ion, whereas the 2 outside the bracket shows there are 2 of them. Okay, and if you remember, nitrate is -1 charge each. Okay, so this is a -1, this is a -1. And there's only one copper, okay? There's no number next to copper, that means there's only one copper. So this copper has to be positive 2 charge. Okay, the reason you have to figure this out is because you need to put the number here, 2. Alright, so this is the name of this guy. But anyway, what I'm trying to show you is this ionic compound, metal with polyatomic ions, and you have to know the charge of it. Alright, calcium is 0, okay? Now, the product of this reaction, you can see that is the calcium displaces the copper in the compound. A nitrate is still nitrate, okay? And the calcium is type 1 metal. It always has a positive 2 charge. So there's a 2 here as well. Now, this 2 was not copied from this 2, okay? This 2 is because of the ratio between the calcium nitrate is 2 to 1 charge. So in order to balance the charge, you have to have 1 to 2 ratio between these two ions. And the copper here, the charge is 0 again, for the same reason. It's a pure element with nothing else around it. So you can see this is called a single displacement, is because only the metal displaces the other metal in the compound and kicking the metal that was in the compound out of the compound. And because it was a solid as the product, so this is also a subcategory of the precipitation reaction. Now, one of the questions usually is, well, it seems like it only takes a metal to kick the other metal out. Why the reverse reaction did not occur? The question is why the copper will just immediately kick the calcium out the back, okay? Well, the reason is there's something called activity series for selected element, or actually for metal, okay? For most of metals, it's mostly for metals, okay? Now, according to this activity series, okay, only the ones, you can see it's decreasing order. The ones in the front are more active than the ones behind. Okay, so according to this activity series, the principle is very simple. Only the ones in the front with a higher activity can displace the ones behind out. So let's take a look at this example, okay. Calcium is located here, whereas copper as an element, okay, is located here. So you can see calcium is able to kick copper out from a compound, whereas copper is not active enough to kick the calcium out of a compound. Now, what I want really clarify this to you is when we say the activities or relative activity between elements, okay, we really mean the neutral element, zero charge, is more active than copper as a neutral element with zero charge. Okay, the reason I want to address this is sometimes it's confusing. Well, when you say calcium, copper, I know copper here is positive too. Am I comparing calcium element with the copper cation here? No, neither the other way around. Okay, I'm not comparing cation versus cation or solid versus cation. I'm comparing between two neutral elements. Okay, now keep this in mind. Okay, this activity series, or when we talk about the relative activity among metals, we always mean the neutral element versus neutral element. Okay, now because of this, okay, sometimes you can easily predict if a single displacement reaction would occur or not using this activity series. Or if you can do a chemical reaction between an element and compound to see if there's a reaction or not, then you can determine whether this element is more or less active than the element that was in the compound. So let's take a look at a few examples. Okay. Now, first of all, by looking at, let's say if we pretending, okay, we do not know the activity series in this case, okay, pretending we don't know this, okay, we completely ignore this, okay, don't look at this. If you are the one doing reaction, okay, let's say you put a sodium into calcium chloride. This is a chloride, right? ID. I want you, challenge yourself. Do you know what chloride is or chlorate? Okay. But if you don't, you may go back to module 5 to practice more. And also, you should make perfect sense to you. This compound has 1 calcium, 2 chloride. For the reason that chloride is -1, calcium is +2, so you have the balanced charge. What's the charge of sodium here? That's right, it's 0. Okay, but anyway, if you put the piece of metal sodium into calcium chloride aqueous solution, okay, this is always going to occur in this aqueous solution. This reaction will undergo, as it's shown here, forming sodium chloride plus calcium. Okay, so this reaction does undergo the way it's shown. Or you can reverse this reaction by putting calcium into sodium chloride solution. Then this reaction will not go. There's no reaction. Now, the conclusion about between either one or the other reaction, okay, they draw the same conclusion. Shows sodium is capable of displace calcium out, kick the calcium out, whereas calcium cannot kick the sodium out. So you can easily conclude that sodium is more active than calcium, or calcium is less active than sodium. Let's look at another one, okay. Aluminum, metal, iron oxide. This is iron 3 oxide, right? So you can crisscross them up. You can show the charge here. All right, so this is neutral metal. This is aluminum is positive 3 charge, type 1 metal. Okay, for the same reason, you can cross down here to form Al2O3 to balance the charge. But anyway, this reaction does undergo. That means aluminum is capable of displace iron out, so aluminum is more active than iron. Or iron could not, no reaction, is not capable of displacing aluminum out, so that means iron is less than aluminum. Okay, either way, that's the same conclusion. Okay, now by looking at the this is one thing. Okay, when you look at the reaction, you can kind of conclude that which element, again, this is between two neutral elements, okay, which is more or less active than the other one. Now let's look at the other way of looking at this aspect, okay, from the other aspect. Now, if you have the activity series, are you able to predict if the reaction will occur or not? So with the activity series, basically you know which element is more or less active. So of course you should be focusing on the metal part or the cation part, okay? Now when you look at the tin and the lead, find where they are. Here they are. I mean, they both are not very active, so you can see they're kind of on this, uh, relatively less active, half. Alright, but tin is still greater or more active than the lead, so that means this reaction will happen also. Yes reaction. Okay. Magnesium plus potassium bromide. Magnesium it's between magnesium and the potassium. Potassium's here, magnesium's here, so magnesium is less than potassium, so that means magnesium is not capable of displacing the potassium out, so there's no reaction. Even though magnesium in general is pretty active metal. Okay, so you can see whether reaction will occur or not. It does not depend on whether you are active or not. It depends on the relative activity between two elements. Okay, so this is the single displacement reaction.